Hello and welcome to Deeksha Karnataka YouTube channel. So in the topic under 30-minute section today, I am going to discuss a very important topic, that is circuit theory. So basically we are going to see some basic elements of the chapter current electricity and the elements from where questions do come year after year. So those important topics we will touch down, and then also we will see how to apply KCL, KVL, and we will see some example problems as well. So let's start without any delay. Obviously this is a short duration video where I am going to discuss the entire topics in less than 30 minutes. So let's start. First, what are all the things that we are going to do today? So we are basically discuss about basics of Ohm's law and resistance, then series and parallel combination, how can you use shortcuts. Next we will use EMF and internal resistance, again shortcuts, and Kirchhoff's laws, basic two Kirchhoff's laws, and how to apply them in circuits. So these are the main things, and some applications of Kirchhoff's law also we will see. So don't worry, we are going to give you everything that is possible today. What are you waiting for? Hit the like button and hit the subscribe button if you have not yet subscribed to our channel. So that's why we are bringing you all these videos and for your preparation of your boards as well as your KCET exam. So please don't forget to subscribe to our channel. Now let's start. What is resistance? Resistance is basically comes from the fact of Ohm's law. Ohm's law says that current is proportional to voltage, and from there we get a term called V is equal to IR. Now this R is basically called resistance. Now this obviously it is coming from Ohm's law. So this resistance is for ohmic conductors. Okay, ohmic conductor means the conductors which obeys Ohm's law of Ohm's law. Basically the definition, ohmic conductors keep R constant, semiconductors do not. So for normal, if the temperature is constant, that is one of the, by the way, one of the constants of Ohm's law, that Ohm's law valid when temperature and physical condition remain same. So that is that there are the two conditions that the Ohm's law has to be applicable, and the conductor has to be ohmic. Okay, normal all the metals are ohmic conductors. Okay, most of the materials that we see around us are ohmic conductors. Basically the conductors that we see around us are ohmic conductors except for semiconductors. So semiconductor is completely different branch. Okay, insulators are there, but insulators are not, we are not discussing insulators, right? So basically and if you see that this resistance can be expressed as rho L upon A. What is rho? Rho is basically the resistivity of the material. It depends on the temperature and the material itself. For example, copper, silver, gold, iron, they all have different conductivities, and based on that we use most of our day-to-day instruments are built using copper, because copper has low resistivity as well as it is cheaper than silver. Okay, maybe silver is slightly better than copper, but it is much more rarer, that's why it's costly. And if you want to build everything using silver wires, maybe what happens, our wires would have been stolen, right? The entire wiring system would have been stolen. Whereas in the exterior part, where the current comes to our house, are mostly built some kind of steel. Okay, even though steel is not super good as copper, but again copper is costlier than steel. Okay, and if you previously in the earlier generation, few 40-50 years back, when the wiring started, they are basically built using copper wire. Some underground cables still today are made using copper wires, but then as you know, a country like India, people started stealing those wires, and then they had to replace it using steel wires. Okay, now so this rho is basically determined by the material and the temperature. L is the length of the wire. Longer the wire, higher the resistance. A is the area of the wire. Smaller the cross-sectional area, higher the resistance. So generally the wires that you see which is carrying high amount of current, the wire appears to be thick. For example, the power supply that is being carried out for high voltage power. Okay, you have seen those structures which are when you are traveling on a train or maybe on a car. You have seen some high voltage high tension cables that we call high tension cable. Okay, basically that carries high amount of electricity, high voltage through them. So those wires are very thick because obviously they want to keep the resistance as low as possible, but not, obviously you cannot make it a super huge. So there are few ways that we will discuss in future, not today. Now the current passing through a conductor can be expressed in terms of drift velocity, and that is given by I is equal to NAE VD. Okay, I is equal to NEA VD is the major expression that you need to remember for your KCET exam. Now N is number density. Number density means you take unit volume of the material, same material, copper, iron, whatever you are talking about. You take unit volume of that material. Okay, we know that every material have a lot of free electrons in it. So if you take unit volume of the material, say a unit cube, okay, 1 meter cube, so there are a lot of free electrons. Okay, so these if you take unit volume of certain material and whatever the number of free electrons in it, that is called number density. It is in the order of 10 to the power of 28 for conductors. Okay, 10 to the power 28, 29, it can go very high value. The number density of electron is given by this N. Okay, A is again area, okay, area of cross section. E is charge of an electron, which is obviously very small, and VD is a drift velocity. So when you apply electric field across a conductor, if you apply an electric field across a conductor, what happens? The electron starts to move in the opposite direction because of the electrostatic force, and this motion is called drift motion. So there are two motions. One is random motion of electrons move in the random direction, which is present every time, even in the presence of electric field or in the absence of electric field. But when you apply an external electric field along with that random motion, the electron slowly starts moving in the opposite direction of the electric field. That velocity is called drift velocity, and that can be calculated obviously, and because of this drifting we see electric current. Okay, and drift velocity is basically very small in value as well. Okay, now if you see this is the circuit. So here, for current to flow in a circuit, we require a source of EMF, which is called a battery. Okay, we have a resistor and a current meter, ammeter. There could be a voltmeter to measure the voltage as well. Okay, so this is the basic circuit, and through that you are expecting some current to flow through it. Okay, current, basically basic circuit. Let's move on. Now when it comes to resistance, you need to remember few traps that basically coming year after year. And if you double the length, if you shorten the length, you are recasting the wire to shorten the length, or the wire is cut into 4 different pieces and then they connected into parallel, what will be the resistance? So these are the few standard questions which have came in the past and which might come in upcoming year as well. So you need to prepare for that, and you don't need to worry too much about it. There is no rocket science here, just simple logic that you need to remember. When you are shortening or lengthening a wire, so this is the original wire, say length L, area A. When you are stretching it, okay, so when you are stretching a single wire, the length will not come automatically. So what will happen? Its cross-sectional area will shorten. Okay, so cross-sectional area gets shortened, length gets increased. Okay, so that means length is getting 2L, area is getting A by 2. Okay, length is getting 2L, area is getting A by 2, so volume remains unchanged. Okay, volume is basically volume is A into L, so volume remains unchanged. Okay, here it is 2L and it is A by 2, this is also AL, right? So volume remains same. So only what is happening is that the resistance is changing. Now how much is resistance is changing? We know that resistance is rho L upon A. So L is getting doubled, area is getting halved, so resistance should be 4 times. Now obviously they might give you a question where say the length is changed by 10%, length is stretched by 20%, 30%. These kind of questions might come. So what you need to remember, you don't need to remember that okay, it will be 4 times or 5 times. You only need to remember that whenever you are stretching the length, the new resistance is n square r. What is n? N is the factor by which the length is changing. Okay, L is the n is the factor by which the length is changing. If it is doubled, n is 2. If it is tripled, n is 3. If it is 5 times, n is 5. Okay, now if suppose there is a question which says that the length is increased by 10%. That was a question came in few years back. So if the length is changed by 10%, then how much is the answer? How to solve in that case? We need to remember, if you increase a quantity by certain percentage, if you increase the quantity by certain percentage, it can be written that the new length is 1.1. Okay, 1.1 times the old, right? If you are, say, increasing the length by 50%, 50% increase means the new length is 1.5. Okay, if the length is, these are all increasing. If it is decreasing, decrease by say 30%, then it will be 0.7 times. So remember, you take one and then add whatever percentage is given, and you say this is the times. Okay, 5 times, 10 times. So this is the n. This is the value of n. If it is given in percentage, which is very common, if you are given in terms of percentage, how to calculate n? Okay, if it is increase, plus, if it is decrease, it will be minus. Okay, if the length is increased by 10%, then you have to add it. If the length is decreased by say 10%, you have to minus it, okay, from 1. Okay, always your starting point will be 1. 1 times means obviously n square, 1 square is same. Okay, so that's why you have to consider 1. So if the length is increased by 10 times, so n square will be 1.1 square. Now you might say, sir, I don't know how to calculate 1.1 square. So don't worry, 1.1 square refers to, if you remember, 11 square. 11 square is what? 121. So just do that, 121. Okay, here it was decimal, 1 decimal, so it will be also 1 decimal. Okay, so first quantity will be out of decimal, and then you have to add the decimal numbers. Okay, so this is the basic idea that you need to consider. Okay, and that is super duper important. These are the foundation of electric resistance. Okay, if the pieces are cut into equal pieces, okay, if you are cutting say a length into equal pieces, okay, you have say a length which is cut into say n number of equal pieces. So total resistance was R. Each of the piece will have resistance R by n. Each of the pieces will have R by n resistance. Right, now when you connect them in parallel, okay, in parallel combination, you need to, I will see that in parallel combination the equivalent resistance will become R by n square. If you cut them into equal pieces and connect them in parallel, okay, their equivalent resistance will be R by n square. We will see that how it is coming when we are going to see the parallel combination, but that is also a very shortcut method. If you remember it, your life will be very simple, and you will say thank you, sir, later on in the exam hall. Right, now series versus parallel. So there are two combinations of resistances. One is series, where resistance is basically added algebraically. R equivalent is equal to R1 plus R2 plus R3. Okay, let me add a equivalent over here. And for parallel combination, it is basically R1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3. So it is a reciprocal addition. It is a reciprocal addition. Here it is normal algebraic addition, no matter how many resistances are there. Now few important things about series circuit: same current through the circuit. So whatever current is passing through this, same current will pass through this, and whatever resistances are there. Obviously we have not, instead of showing multiple resistors, I have shown only 2. Okay, obviously that is, please forgive me if you think, sir, what is the third resistor? It is in the series, in the same order. I have not shown it. Okay, voltage divides in the ratio of resistances. Okay, so voltage divides in the ratio of resistances. Suppose you have added a voltage of V. Okay, whoever has higher resistance, voltage across it will be smaller. Okay, sorry, voltage across it will be higher. Okay, resistance, so suppose this one is V1, this one is V2. Okay, so V1 is to V2 will be R1 is to R2. So the voltage divides in the basis of resistors ratios. Okay, but yes, based on question to question, we may need to change it. Sometimes we need to apply Kirchhoff's laws and find the exact values. Sometimes we can use the ratios to find the ratios. So if the question is coming that, okay, our 1 ohm and 2 ohm resistors are connected in series across voltage supply of 10 volt, what is the ratio of voltages across them? So it will be 1:2. Okay, same as their resistances. Remember that. Okay, that will save you some time. In case of parallel combination, remember that the voltage across each of the resistors are same. So if you connect them in parallel combination, voltage across each of the resistors will be same. Okay, so same voltage across each resistors. Current divides inversely with R. So suppose this one is having a current I1, this one is having a current I2. Okay, I1 is to I2 equals to 1 by R1 is to 1 by R2. Okay, so the current divides in the ratio of inverse of the resistances. Total R is always smaller. Here total R is always greater than the bigger resistor. Okay, here resistance decreases, overall resistance decreases. Here obviously overall resistance increases. This is obvious. This is sometimes can be tricky. So if you are say connecting parallel combination of 1 and 2, the equivalent resistance will be smaller than 1. Okay, so the overall resistance decreases in parallel combination. Okay, now let's move on. So only 2 resistors are connected in parallel. If 2 resistors are connected in parallel, the equivalent resistance shortcut is R1 R2 divided by R1 plus R2. Most of us know this shortcut. This one is a common shortcut. But if n equal resistances each of resistance R are connected in parallel, then what to do? If n equal resistances each of the resistor R are connected in parallel, okay, then can you do any shortcut? You don't need to add them in the formula. You directly calculate the equivalent resistance is given by R divided by number of resistors. Take any one of the resistance, divided by the number of resistors, you will get R by N. Many cases you will see 2 resistors in parallel having equal value. Do not use this in that case. You can use this formula, but if you see that say 5 ohm and another 5 ohm, they are connected in parallel, then their equivalent is whatever it is, it will be 5 by 2. You don't need to bother about it. It is very simple and easy. You don't need to apply all these formulas. Okay, 5 into 5 divided by 5 plus 5. You will get 5 by 2 only. Right? So this is more common. 2 resistors equal value connected in parallel. The equivalent resistance will be 5 by 2. Okay. So n equal resistors, it will be R by N only. Okay. Now one resistor is far smaller. Okay, 1 ohm with 100 ohm gives 0.99 ohm. Estimate then match the option. Okay, so suppose you are connecting a very high value resistance with a very small value resistance in parallel. There is a tendency that the equivalent resistance will be closer to the smallest resistance. Okay, if you connect say 100 ohm and 1 ohm, okay, the equivalent value will be closer to 1 ohm. Okay. Series, total, parallel, series by number of series. Suppose you connect certain resistors in series and then parallel, then series total divided by parallel total will be n square. Okay, if you connect n number of resistances in series, same value, okay, the equivalent resistance will be n into R. Okay, in series it will be n into R, in parallel R by N. So n into R by N turns out to be n square R. Now let us look into the question that I left. I will not leave anything behind, as I mentioned. So suppose there is a wire, I cut it into n equal pieces and then I connect them into parallel combination. Okay, the wire has some resistance, right? The wire has some resistance. Now I connected them in parallel combination. So each of them had resistances R by N, R by N, R by N. Now each of them have R by N, right? So how many of them? Total n of them. Each of them R by N. So total equivalent resistance here will be R by N divided by N. This is from the parallel combination shortcut. right? This is from the calculation R by N. So suppose I have a 100 ohm resistance. I connect into 10 pieces. Each piece will have 10 ohm resistance, right? That means that is obvious. Now if you connect them in parallel combination, then total resistance will be only 1 ohm. Okay, so that is one that you need to be careful about. So R by N square. Okay, so this is a shortcut formula, very handy in many cases. Now EMF versus terminal voltage. Now when you connect a cell across an external resistance, if you take a voltmeter and measure the voltage across this terminal, you will see that the voltage is less than the actual EMF of this cell. Okay, this voltage is called terminal voltage. This voltage is called terminal voltage. Now terminal voltage, if there is no external resistance is applied, then terminal voltage is equals to EMF. But if there is an external EMF is applied, then obviously the overall what should I say, the overall terminal voltage will be reduced, and that terminal voltage is given by this formula, E is equal to V plus capital I into small r. This can also be written as equals to I into capital R. Okay, some cases we might use I into capital R, so I is known. If I is known, I into R is same as voltage. Okay, or in some cases it will be E equals to, E means the EMF equals to V plus IR. Okay, or V equals to terminal voltage E minus IR. Okay, current passing through the circuit, however, basically using near normal Ohm's law, two resistors in series. Okay, so equivalent resistance is R plus R, and if you divide epsilon, you will get the, or E, epsilon or E, you will get the current in the circuit. So E divided by R plus R gives you the current. Use this current to calculate terminal voltage. Okay, now when the circuit is open, I equals to 0. Discharging being charged is not there. So short circuited, R is equals to 0. If you short circuit is this, obviously R is equal to 0. If you open the circuit means you completely cut the resistance out, current will be 0. Okay, charging discharging is not there. We are not going to discuss that. Now if n number of cells in series having equal EMF and resistances, the current, this is a shortcut formula, for n equal valued EMFs are in series, the current in the circuit is n epsilon divided by R plus NR. Remember, this is a very important question for MCQs, for boards, for plus for KCET as well. Okay, so epsilons add up, resistances add up, this one remains same. Okay, now what else? M number of cells in parallel. So we are just using a separate value, M number of cells in parallel. Okay, then the I becomes M epsilon MR plus R. Interesting. So the things change, switches only in the division. So if they are in parallel, it will be M epsilon divided by MR plus R. Okay, so in parallel combination, the resistance, the internal resistance is okay, the external resistance itself increases. Okay, so actually the EMF remains unchanged, and that to adjust that portion, we have done this like this. Okay, now mixed grouping, you need to calculate the equivalent resistances, and then you have to calculate the resistances. Mixed grouping is okay, based on problem to problem, we will see if it is, this formula is required or not. Okay, current peaks when external resistance matches the total internal resistance. So that is one important point when you are talking about the maximum current passing through the circuit. The current is maximum when the external resistance is exactly equal to the internal resistance, and that brings out to the maximum power transfer in a cell. Okay, when this is also points, these are all important points for objective questions. Okay, these are all important points for objective questions. So whenever it says that maximum power transfer, power is maximum when this P is maximum when R is equal to small r. Power is maximum when R is equals to small r. So internal resistance and external resistance, if they become equal, power becomes maximum. Okay, so P max equals to epsilon square by 4R in that maximum case. Okay, P max equals to epsilon square by 4R. Okay, that is the maximum power dissipated in the circuit. Okay, efficiency at that peak point is only half, even though efficiency is not there. But remember, even though the power dissipation is maximum, efficiency is not maximum. Okay, now Kirchhoff's laws, there are two Kirchhoff's laws. So far everything, because it's a rapid revision, we are doing it little faster. So Kirchhoff's laws, what is the Kirchhoff's law? First law is junction rule. So junction rule states that at a junction, okay, basically whatever the incoming current, that should be the outgoing current. Whatever is the incoming current, that should be the outgoing current. Suppose some currents are going in, some currents are going out. So whatever the sum of the incoming current, that should be the sum of the outgoing current. That comes from the fact charge is conservative. Charge is conserved in a given case. So that means whatever charge is coming in, that charge has to go out. Charge cannot stay. So hey, I will go tomorrow, you can go, you go ahead, I will come tomorrow. No, it's not happening like that. Charges, whatever charge is coming, that same amount of charge has to go out. That means at a junction, the current incoming should be equals to current outgoing. So that is if sum of I equals to 0. Now what about loop rule? Loop rule basically can be explained in two ways. One of them is that if you go by a loop, complete loop means starting point, ending point has to be same. If you go by a loop rule, sum of V must be equals to 0. Sum of potentials at a point must be 0. Okay, so round any closed loop. Now what I generally prefer is that so there is a sign convention mentioned, I will explain it. So what I generally prefer, that suppose we have a circuit, I will give you one example, small KCL example, not KVL. KVL demands more time. If you want particular KVL example, please mention them in the chat below. Suppose this is a complex circuit, part of a complex circuit, some current passing through this, some current passing like this, some current passing like this, some current passing through there, some current passing through there. Now one very important point to remember, whenever there is a cell involved, whatever current is exiting the cell, the same amount of current always has to come back to the cell. Okay, that is point number 1. So whenever you are, suppose in a cell they have added some resistance, don't worry, if there is a cell involved, whatever current that is exiting the cell, same current has to come back to the cell. Again, conservation of charges. So if I current exit, I current has to enter. Clear? Now when you are going in a particular loop, when you are going in the direction of current, everything is positive. Everything is positive. We apply simple Ohm's law. Okay, suppose this is resistance R1, current I1, this is R2, current I2, okay, R3, I3. So you have to start at some point, you have to end at the same point. When you are going in the particular loop, you need to remember, whenever you are going in the direction of current, everything is positive. If you are going in the opposite direction of the current, then it will be negative. So for example, I2, R2 is negative. So I1, R1 is positive because you are going in this direction, along the direction of current, but your target is to close the loop. To close the loop, you have to go like this, but the current here shown is going in the opposite direction. That means it will be minus I2 R3. Okay, and then from here to here again you are going in the direction of current, so I3 R3 is positive. This is basically Ohm's law, right? This is Ohm's law, I3 R3, and that should be equals to EMF of the cell. Now remember, if the cell is sending current in the same direction as your loop, okay, when you are going in the loop, if the cell is also sending the current in the same direction, then on the right hand side the cell will be positive. On the right hand side the cell's EMF will be positive. So that's how you should remember, and whenever you are applying Kirchhoff's law, no matter how complicated the circuit is, if you follow these basic rules, you should be able to construct equation and solve them. Obviously it requires a lot of practice, so we might do that in the future. Now let's move on and solve one problem. Okay, here this is a question from 2026 this year. Okay, so 5 ampere coming from here. Then you see that 1 ampere coming back here. So 1 ampere coming back here means obviously current has only one path, so 1 ampere should come from this side. So how much current is this? So 5 ampere going in, 1 ampere coming out. So remaining current has to go out. So that means 5 minus 1, that is 4 ampere. Okay, so this I1 is 4 ampere. Now 4 ampere going in, 1.5 ampere going out. That means remaining current in this direction will be 4 minus 1.5, that is 2.5. Now 2.5 ampere going in, 1.5 ampere going out in this direction. That means here the current will be 2.5 minus 1.5, that is 1 ampere. So the current I1, I2, I3s are 1 ampere, 4 ampere, 2.5 ampere and 1 ampere. So that was the question. Then in the option, multiple options were given. You need to choose the correct option. So this is the end of today's session. If you have any questions and any suggestions, please feel free to add in the comment section below. But before I go, if you want to join our free KCET batch, just hold on with me. I will show you how to join the batch. So you go down in the description section of this video. Okay, and you will see that join the free ACE KCET 2027 course. Click on here, and once you come over here, you will see that it is mentioned ACE KCET 2027, 0 rupees. You don't need to pay anything. Just click on buy now and you will be redirected to our homepage, and from here you will see all the lectures that we are doing along with the class notes, etc. So for all major lectures you will find the class notes. Quizzes, assignments will also be added here very soon, and we have started adding the assignments as well. You will get those as well real quick. So that's how you should learn freely without any pressure, without any monetization. So that's how you should join our free batch, YouTube batch, obviously, but without any restriction, along with a lot of extra materials, class notes. You will get the free assignments, free tests, etc. So do join today itself, don't wait, and I'll be back with more lectures. Till then, bye.